With these objectives in mind, several cruises were carried out in the Cretan Sea in 1997 and in 1998 by the IMBC research vessel Philia. These research cruises went under the codename of Talos. Why Talos? Well, he was the mythical bronze giant of Minoan times who, legend has it, circled the coast of Crete every day, protecting the island from potential invaders. The modern-day surveyor, the RV Philia, carries out its protective task, equipped with modern oceanographic and navigation instruments, and it can undertake extended missions in the open sea. During each cruise, different kinds of sampling methods are used. Collection of tar, floating litter and seawater was performed in an extended grid of sampling stations, and simultaneously, hydrographic measurements of the water were taken at each station. To find out just how bad tar pollution in the Cretan Sea had become, tar samples were collected from the surface of the water. Working night and day, these samples were taken by a special sampling device constructed by IMBC. This consists of a catamaran carrying a steel frame with a nylon plankton net. The sampler was then towed outside the range of the ship's wake at a speed of some 3 to 4 knots over a distance of 1 nautical mile. Attached to the end of the net, there is a collection pot made of Teflon. After each tow, the material was collected from the end cup, separated, and then stored. For every tow, the exact coordinates of the starting and end points were fixed by using the navigational equipment of the vessel and an advanced global positioning system. This allowed a final estimation of litter and tar concentration per square meter to be calculated. Now, knowing the level of tar pollution is one thing, but equally important is to discover exactly where the tar comes from. In order to find that out, the movements of the tar and its pathways had also to be determined. This was done by using a salinity and temperature measuring device called a CTD. By collecting vertical profiles of these hydrographic parameters and processing them with special analysis techniques, it proved possible to obtain the surface circulation of the water at the time of the research cruises. Complementary information was collected from satellite thermal images over the cruise period. These images were provided via the internet by a land station located in Germany. In each station, water samples were also taken 1 meter below the surface using a special 2.5-liter sampler. Dissolved and dispersed petroleum hydrocarbons in the water column were extracted on board Philia. Then, after each cruise, total hydrocarbon concentrations in the seawater were determined using a spectrofluorometer. These results, taken along with tar concentrations, can give very useful additional information about the distance of the sampling station from the point of the initial discharge of oil into the seawater.